I'm actually thrilled that I got a chance to hear a little bit of the preceding talk because it's going to kick off a lot of what I want to talk about. If you don't know who I am, then you're lucky. Most people regret it. But I've had a long career in machine learning and AI, starting way back in 1999. And what's interesting, given our discussion we just heard about skin tone and race and the complications of trying to understand a face using machine learning, it seems like the perfect opportunity for me to share where I started. The very first ever project that Vivienne and Ming worked on in machine learning, which, by the way, I didn't choose. I had actually thought early in my career I'd be a wet neuroscientist, which is to say, I'd stick wires into cat brains. It's not admirable, but it's the way we understand how these things work. And I loved that work, but then a professor of mine said, you got the highest grade in my class. And it was in learning C for cognitive modeling. I don't know if anybody uses C anymore for the purpose of building low-level machine learning models, but that was what the course was in. He said, I hope you don't mind. I've recommended you to be a research assistant in the lab of a friend of mine. And that lab was called the Machine Perception Lab. And perhaps not coincidentally, given the last talk you just heard, what we were trying to do with money from the CIA was real-time lie detection off of facial analysis using machine learning and raw videos. Now, there is so much we could talk about, the very gray morality of doing this, what it actually meant even to do facial tracking and expression analysis in 1999. But what's interesting is at that time, I was an undergrad, and it just seemed so cool, so amazing that I could build, in this case, a 3-layer neural network with Gabor filters that could analyze a face and tell that it was smiling. Not that it's happy. Turns out that's a much more complex story. But that in 1999, I could do a thing with a machine that felt so fundamentally human. But it was also the same year that I saw how complicated it was, how fraught. There was a famous computer scientist, Paul Viola, going around and showing off the best-in-class face tracking system that he had developed. It was a cascade of Haar wavelet filters, which, by the way, is still a standard that's often used today. And he did a demo. He came to our university, as he had many others from MIT and Compaq. MIT still around, Compaq not so much. And he did this demo, and it was so impressive to actually see in real time. He could take a picture of the audience in front of him, and it found every single face. It felt just instantaneous, again, on a 1999 computer. And then he showed some demos of different photos, like classics. And he showed the crew of the Starship Enterprise. And it found everybody, except one person. And I bet after the last talk, you can probably guess who that person was if you're a Star Trek nerd. It was Uhura. And me being an undergrad aspiring to be more, I felt empowered to stop this famous scientist in his tracks and say, wait, what is going on here? Why is it not finding Uhura? And he said, it's a known problem. We've trained our facial recognition system on the internet, and the internet, circa 1999, is overwhelmingly white. We're going to fix this. Don't worry about it. And that was my first introduction to the idea that machine learning was up to some amazing technical challenges, that it could do truly astonishing things. And needlessly, in the more than 20 years since, it's done some very amazing things. And I want to take you on a little tour through some of those. But I also want to take you through a tour, not just of my career in the braggy, here are cool models I've built and amazing applications, though I hope they feel fun, but also the problems that emerge out of doing this when all you care about is showing off how smart you are and how cool your models are. And one of them is this idea that it's okay for a facial recognition system to simply not see people, in this case with dark skin. And even worse, to say, it's a known problem, we're going to fix it. Because 20 years later, we are in many cases still struggling with literally that exact same problem. He was right. It is fixable. But we haven't truly made the hard choices in the machine learning community to make those fixes. So, here I am with my Pixel and my Pixel, and I got to control some slides with this thing. So let's slides. Okay, I'm not seeing them. There we are. So here's just a sample of what we were actually doing at the time. That was one of the PIs on the project, Marty Stewart Bartlett, showing off. Again, I get it. It's almost 2023, but imagine it's the year 2000. And in real time, you can smile and you can laugh, and a machine could track those expressions. Again, super important, not necessarily emotions. People express emotions in a much more complex way. But those basic expressions could be picked up in real time. And I went from someone who thought that they were going to understand neurons and glia and the system of the brain to someone who thought, here's another kind of intelligence. Could we use this to understand ourselves? And my little talk here today is going to be a tour through a number of projects, not simply talking about how cool it is to be able to recognize an expression, which probably feels pretty off the shelf today. But what does it mean? What can you do with being able to recognize an expression? So this is where I got my start. And I'm going to come back to the story of facial recognition. But by training, I'm a theoretical neuroscientist. After I did my undergrad at UC San Diego, I went around to universities across the US, and I told people that I wanted to build cyborgs. I know that is hardly the rational thing to say to you, because when you are an aspiring grad student with a pretty shifty history, as I might touch on later, when someone asks you what you want to research, and you lean into them and say, I want to build cyborgs, turns out what they do is they scoot away from you on the seat for fear that your crazy is going to rub off, and they won't get in either. On the other hand, the first person I ever said that to told me they wanted to research a protein cascade in yeast. You may not have realized it, but to molecular neuroscientists, we're all approximately yeast. But I wanted to do something that was different, something that combined machine learning and the understanding of the brain. And to me, the word for that, being a sci-fi nerd, the word for that was cyborg. The word for that was, or the phrase was, how do I make a better person? In this case, literally. And in my particular area, I really wanted to understand how the brain actually coded up information using information theory. And so my next slide shows a little bit of what I did as a grad student. What you're seeing here is a bunch of just random noise. It's a nerdy audience, so I'm going to talk to you like nerds. So this is starts as just a dictionary of Gaussian noise kernel functions. But what our system did, what I literally did, was wander around parks in and around Pittsburgh, Pennsylvania, with a microphone and a computer. And this thing just listened to the sounds in the world around it. The babbling of a brook, the wind through the leaves of the trees around me, or when I stepped on a stick, the snapping of a twig, just the sounds of the natural world, a snippet of bird in the background. And from that, you can see a very condensed training here of it learning, if you will, a language of sound, learning a set of functions that capture the most information about the auditory natural world, while also doing it with the least number of bits to encode that information. Some classic information theory. And it turns out that what this thing learned is almost identical to what our brains do. What cats and gerbils and humans, our cochlea, use the same language. And, it was fascinating. And there were some unique tricks here. I started this project in 2001. And back then, doing an actual learning system using an idea like convolution was pretty new. This result you're seeing here got a big paper at NeurIPS. It was NIPS back then, but NeurIPS now. I got into Nature. I felt so excited. But I wanted to do something with it. I mean, I loved the science. I loved the way we could geek out and think about a truly new way of coding information and a new way of building an ML system that interacted with the natural world, that learned how to hear. But for me, that wasn't the end of the story. For me, it didn't end with a fancy scientific publication or the bragging rights that I was ever so briefly a top nerd. What does this mean? How can we use it in the real world? Especially if, like me, you wanted to use AI to build better people. So we took that model and we used it to learn the optimal filters for a cochlear implant. So this is essentially a hearing aid, an artificial device that literally wires into the brain, the 8th cranial nerve, and it translates sound into neural impulses. And what we found was that our model dramatically improved people's ability using a cochlear implant to hear speech sounds in a noisy environment. And that felt so much more fulfilling to me. That had so much more potential impact on the world than simply publishing a paper and saying, look how smart I am. And even by that early point in my career, I realized I was hooked. I loved the idea. Maybe my favorite talk of all time was one on the mathematical isomorphisms between Gabor wavelet filters, a model of coding in our primary cortex, and wave packet theory from quantum mechanics. It may sound like two completely different things, and to many people, all of those words sound like nonsense. But to hear it work out, if you wanted to find the optimal solutions to time frequency uncertainty, it turned out you needed the same type of a function as finding the optimal solutions to position and momentum uncertainty. Wow, that was nerdtastic. I loved that presentation. But for me, I wanted to touch a direct life. This idea that people could hear because of something I'd built. The idea as an undergrad that this thing that I'd helped develop in my small ways, my undergraduate honors thesis was a neural network that found your philtrum, this little thing under your nose. What a tiny claim to fame. And I loved working on that, again, for intellectual reasons. But later, I had the chance to actually do something with that. And Maybe we'll just jump to the next slide if someone else can control that for me, because my phone keeps going to sleep in between my slides. But I can try. And what I had the chance to do a few years later, I'd finished my dissertation. I'd had a joint appointment at Stanford and Berkeley, and I loved the work I was doing there. But I'd started a startup. My wife and I had this idea of something we could do together. And that idea got some attention. It got some attention from a group called Refugees United. And their corporate sponsors at the time, Ericsson, and it was part of the UN's Millennial Cities Initiative. And jump back. There we go. So it, oops, one more forward here. There we are. I think now people are conflicting with one another. So I had this chance to work on a project, and you're seeing some faces right now, very similar to our little noisy functions that we built to understand sound. Here was something new as well, little noisy functions to understand faces, a big, giant dictionary of faces. But here it's 2008, 2009, and this new idea was coming in. And everyone was excited about it. And it's the idea of extending networks beyond a single hidden layer. So I'd worked a lot in unsupervised networks through the early part of my career, for example, using convolutional sparse coding networks. But here we wanted to build something with multiple layers, a system that at the first layer understood faces and their physical characteristics, but on the next layer understood how people perceived faces. What's a competent face? What's a happy face? What is a face with ennui? And so we built this model, and here you're just seeing a tiny snippet of the dictionary learning, starting from noise. And again, in 2023, this is old hat. But in 2008, what we'd been asked to do was to help reunite orphan refugees with their extended family members. That same technology that as an undergrad, I'd learned something about for this very gray idea of helping the CIA detect lies, I was now able to use it and extend it into something, the very early days of deep neural networks, extend it into a system that could actually help someone who hasn't heard from their sister in months, their sister who lives in a war zone, and they're fearing the worst. And so they travel to a UN refugee camp. And, 20 years ago, that meant they gave you a book. And that book had thousands, million photographs in it. Little kids lost in camps around the world. And we were able to build a system on a tablet that allowed you to say it picked 18 random pictures out of that set, and you'd click on the ones that look more like your niece. And after 3 to 5 screens, 5 minutes of time, if she was in a camp anywhere in the world, you found her. Now, again, there were some cool technical advances here, aspects of those early days of building an extended network. There was also the work we did in applying this to understand some of the weirdness of the internet. Why it is faces of certain kinds of people are overrepresented, and some of the biases we pick up on from seeing overrepresentation of faces such as women smiling on the internet, much, much more so than men. And in our heads, smiling and youth becomes associated with femininity, and competence and age becomes associated with men, And it turns out part of it is because that's what the pictures are telling us. That was great. Again, I love being a scientist and I love these little technical breakthroughs. But the idea that in 3 or 5 minutes, someone could find their niece and pull them out of a refugee camp and bring them into a loving family. That was why I wanted to do this work. And in fact, that wasn't the only work I had the chance to do. In my next picture here, you'll see a little claim to fame. This is, I was told at the time by the Google Glass team, the first and only presidential portrait ever taken by Google Glass. Very early days, I was invited in by the Glass team to come up with ideas of things to do with Google Glass, which was really cool, to be able to think not so much about the engineering, it wasn't my side of things, but what can I do as someone that works in studying both artificial and natural intelligence? And it seems so obvious. In fact, there are several existing use cases here today, but I thought I could use that camera and I could analyze a face and I could figure out the expression and put it up on the screen. And boy, you could do that for the CIA for the lie detection. Though it turns out detecting lies is way harder than that. And it never works so great. I suppose you could float everyone's credit scores over their heads so that bank managers knew who to give loans to. You could do a lot of things that are terrible ideas. What we built was a system for autistic children. What they'd see is either the actual expression written out, happy or smiling, or just simply an exaggerated emoji right up in that heads-up display. And from that, we actually found that they could learn to read facial expressions faster than they could using the state of the art, which in some ways still today is a cartoon flashcards. But it turns out that wasn't even the end of the story. Again, this use of a very controversial technology, facial analysis, ML. But in this case, what we found was, as the kids not only learned to read facial expressions through natural social interactions using glass, they also learned theory of mind, empathy. Turns out it's really hard to understand why someone is happy or sad if you can't understand the signals that they are. You can't see the frown or the smile. It doesn't mean something to you intrinsically the way it does for many of us for free. And that was an amazing bit of finding. But again, a place where I found I could turn my love of numbers and computation and this idea of taking an idea out of science fiction and bringing it into the real world through machine learning and turn it into something human. My son has autism. He's a very high-performing kid, but take him to the dentist and you see it clearly. Watch him through his day at school, where he will simply wander out of the classroom because the social stress is too much for him. And you get that there's a different language being spoken. We're trying to have a conversation with someone who's only hearing shouting and in an accent they barely understand. And here was a chance to make a difference. In fact, the next photo is of my son, because he not only has autism, but it turned out fate really wanted to load up on this kid and give him some serious obstacles to overcome. His next picture, whoops, sorry, my fault, is him. And one of my more notorious projects I ever worked on. In 2011, my son was sick. It was just before the US Thanksgiving holiday. It was that Sunday leading into that week. And he threw up in the bathtub. And God, if any of you have kids, there's stuff coming out of every orifice on a regular basis. You know, he was only 3 at the time, and these things happen. But he was still sick the next day. And by that Wednesday, he couldn't stand up anymore. He'd lost, about 15 kilos of body mass off of a 3 turning 4-year-old frame. And we rushed into the doctor and got the diagnosis that he had type 1 diabetes. Now, the following components of those stories, I don't necessarily highly recommend, but what really shocked me wasn't that long weekend that we spent in the pediatric intensive care unit. It was a month later when we went in for our first outpatient visit, and my wife and I, both being scientists, brought all of this data with us, thinking they're going to love us. Oh my goodness, they did not. They were angry with us for wasting their time. And so I thought, this is crazy. I build models of the brains, and my son is being treated by looking at handwritten numbers by eye for 30 seconds. And I liked his doctors. I liked his endocrinologist. But I figured there's got to be something better than this. And so I hacked all of his medical devices. It turns out I broke all sorts of US federal laws. And I built, little did I know at the time, quite frankly, 2011, I was shocked that this is true, but I built one of the very first AIs, ML systems to treat diabetes. And yes, you should not necessarily hack medical devices. Google definitely doesn't advocate for that. But the whole movement in diabetes has a name. We are not waiting. And here was a chance where this mom just happened to know something, a thing that could give her a superpower. And so I built that superpower, that anywhere in the world, I would know not only what my son's health state was, what his blood glucose was, but I would build a system that could predict it an hour into the future and send me updates whenever it was predicted to go high or low. So if you're wondering on the previous slide why I was wearing Google Glass to the White House, why the President of the United States was at all interested in meeting me, it wasn't about diabetes. It was because of some things we're about to talk about. But the reason I was wearing Google Glass is because I built that superpower for myself. And while I was in Washington, D.C., my son was with my sister back in the Bay Area in San Francisco, and I got an update, an alert in real time that said in 30 minutes, Felix's blood sugars will go dangerously low. And I simply sent her a text and asked her to give him some crackers. I can tell you, there is nothing that feels better as a parent than believing that you were the one person who could truly make a difference in your child's life. And then there's nothing more awkward than wearing this superpower, fluorescent blue, by the way. I was given a couple of different Google Glass over the years, but the one I ended up with at the White House is fluorescent blue. At a fancy dinner, I had a fluorescent blue computer in my face, and the Secret Service freaked out. Instead of kicking me out, the president decided to meet me instead, and I got to tell him about how I broke a bunch of federal laws to build a machine learning system to track my son's blood glucose levels. And he was a very good spirit about it. The truth is, when he first walked up to me and all he could see, that Secret Service had pushed everyone else away, and it was just Barack Obama and, I don't know, Lord Nelson there. He simply looked at me with my fluorescent blue computer on my face and just shook his head like a disappointed dad. But then I got to tell him why I was wearing this, what it meant to me. Not to make of this photograph. By the way, my first words to the President of the United States were, "Okay, Glass, take a picture." So that's the picture you're seeing. He wasn't super amused by that, to be perfectly honest, but I get to tell him about my work in diabetes, about this idea that you could take at the time, still largely arcane technology, something that people still thought of in terms of science fiction, and actually help a real person. It was an amazing thing, and amazing that I got to share that story with the President of the United States. And I got to help my son at the same time. And maybe the best punchline of the whole story was we got to just give that model away. There was no patents. I didn't start a company. I had helped my son. That was the reason that work existed. And I then got to go talk to people at any number of companies around the world, Eli Lilly and Novo Nordisk and Medtronic and others, and just tell them how to do it too. No patents, nothing. Whenever my son is having a hard day, and as you can imagine, a kid with autism and diabetes, he has hard days. I get to remind him that there are people alive because our family was able to do this and give it away. That as hard as this is for him, maybe we were the right family for it to happen to, so that other families don't have to do it alone. Again, this idea that machine learning and artificial intelligence can be more than an intellectual exercise, more than a business plan for a startup. It can be a tool to change someone's life is incredibly important. But how about that company that I mentioned? My first startup was in education. This was before Khan Academy really became a thing, before Coursera. And we were going around to venture capitalists, my wife and I, and saying, we built the system that listens to students talk to one another. I know we live in the world now of BERT and Lambda and Chat GPT, but back then, we were just exploring in my work the ability to actually take, let's say, university students, chatting online with one another, listening to their free-form conversations. These weren't pieces of work. It was just course-level social network conversations. And we were able to actually predict the grades the students would get in the class. Now, let me be super clear. I'm not a fan of automated grading systems. What we were trying to communicate was, if we know these 3 students are going to fail your class, here are 3 amazing things you could share with them that for students like that had helped them find success. We built dashboards that allowed teachers to explore what was going on in their classrooms, how, for example, the sentiment of feedback could help some students, a little tough love, while devastating other students and ruining their academic outcomes. The same behavior, different outcomes, and trying to understand that every student was different, but they learned in slightly different ways, and that we could build a system. So what you're actually seeing on the right side of this image is one of those courses. Every one of the dots of this sort of turquoise bird that's flying around is a 3-dimensional embedding of a 100-dimensional deep embedding space of conversations that were happening in this class. Each one is a post. And then a little bit over time, you see a touch of color coding. And we could see when and where to intervene for faculty to come into these conversations and help students get past misconcepts and help them move through the course and make recommendations that could help. Needless to say, when we were launching this project in 2008, we go to VCs and describe it, and they'd say, you can read students' minds, because that was as much as a venture capitalist understood AI back in the day. And hey, far be it from me to disabuse someone of the notion that I could read people's minds with ML. But instead, in that context, they would then say, here's $2 million if you do financial fraud detection. And I have the perfect CEO for you. So right there, my entire business plan has changed. Not education, financial fraud detection. Oh, and by the way, I was already the CEO sitting across the table for them, but not as far as they could see. I was out of that picture. Needless to say, I didn't take the money, but everyone saw And I have to say, in retrospect, correctly, that our machine learning models could, in theory, make more money in the finance industry than they could ever make in education. And they're probably right. But I wasn't there to do risk analysis. I wasn't there to do micro trading on millisecond scales. I wasn't there to do the things that would maximize the revenue that would come back. I was there because I wanted to make a difference in learners' lives. I started a company because I thought that there was enough intrinsic value in that it could be self-sustaining, that it didn't have to just be an academic project or a philanthropic project. That it could be something that could grow on its own. And nobody at the time wanted to invest in education. And nobody sure as hell wanted to invest in my wife and I. In the end, we got pushed into using language models to analyze unstructured log files, which sounds incredibly dull. It is incredibly dull, but it was a real business, and we were able to sell the company and move on to my next work. But what I realized doing that, and through other projects that had left up to that moment, was that there was something more important to me than whether I had a paper in Nature or whether my startup was headed for the IPO lottery. There was a life that I wanted to change. And there was the tools I had, in this case, neuroscience and psychology and machine learning, that could help change those lives. And that it didn't really matter what anyone else thought, that there's a degree to which I needed to make my own choices about what was important. And not allow other people to make those choices for me. Oh, actually, if I go back to this previous slide, there's another scatter plot there. Just at an amusement sense, one of my next companies, I was the chief scientist of one of the first companies doing AI in hiring. And it turns out, wow, is that a fraught and ethically complex space as well? But our claim, challenging as we found it, was that we wanted to make tech hiring fairer. And a number of companies, some very notable ones that might even be involved in today's presentation, were our customers. And it felt so great to go in there and build models. We built a data set of 122 million people, tens of thousands of employers, looking at what things predicted the best career outcomes. If you wanted to hire someone amazing, and there are only so many graduates from Oxford and Stanford that you could staff your company with, you wanted to find all of those other amazing people, what do you actually look for? I'm going to answer that question on my next slide, but this was a funny little side project. Next to our turquoise bird is this weird cloud of sort of grouper-like scatter plot. Again, it's a 3D plot projected down from, in this case, more than 100 dimensions. It's a psychological profile of entire companies. Someone had published a paper showing that they could analyze social media profiles and predict people's big 5 personality characteristics. And I thought, that's interesting. Could we do that for companies? Could we actually model companies' cultures as personalities and then find good matches, cultural matches for employees and employers? And in this case, you're seeing an embedding along that horizontal X dimension. For example, you're seeing companies plotted out in terms of how employee-driven versus management-driven they were, which is just a discovered dimension from an unstructured analysis of applying a personality model to every employee in our data set, and over 100 million people, and then aggregating it hierarchically to all of their employers, assuming that the data we had on the employees told something of a story of the culture of the employer. And it was fascinating. Companies in Washington, D.C. were way over on the management-driven side of things. We could even have a generative model, and it would generate some text. not nearly as good as the kind of models we use today, the large language models. But back then, you could sample from a generative distribution and kind of look at what is a statement someone might make on their resume if they were a good fit for a management-driven company. And for software engineers, it would say something like, I am an amazing engineer. If you give me a set of requirements, I will return to you a high-fidelity product. And then you'd look at companies like Google, way over on the West Coast in the tech industry, way over in the employee-driven side of things. Back when I did this, I think 2013, and their generated was, you lucky bastards. Because you have attracted my attention, I will help solve your problems for you. And they were more likely to use words like creativity than they were to use words like agile development. It was really interesting seeing this, again, using machine learning to understand people, and in this case, even cultures. Understanding that in some ways, some of the bias that we often struggle with in the models we build shouldn't just be seen as a flaw, but can be seen as a diagnostic tool to understand ourselves. Yes, there is gender and racial bias in the American literary canon, and the models that showed that were fascinating and told us so much about ourselves. Unfortunately, in the news, it simply said, AIs trained on books are racist. You've lost the nuance of what this can show us, the mirror that this can be for understanding ourselves. But I had promised just briefly, if you were curious, what were the things that were predictive of people's long-term career success? I imagine some of you were probably early in your career studying machine learning. You have visions of the things you could do. I hope I'm telling you something a little bit different than a lot of the classic stories of AI, a lot of the standard uses, cool as they may be, building a chatbot or using AI for some kind of targeting purposes, that's a purpose. But using it to understand people, using it to help build better people, that's a real possibility too. And here we used it to find what actually predicted people were good at their careers. And it turned out we included universities in here. We included course loads and the degrees people earned. But they just, once I knew other things about you, the things you're seeing on the slides right now, things like your cognitive abilities, your social skills, emotional intelligence, for example, your resilience or sense of purpose, turned out to be a bigger predictor of the quality of code written by professional software engineers than the school they got their degree from. That was an exciting finding. And again, what an amazing thing to learn something about us from studying using the tool of machine learning. It was an incredibly fun project to work on. Now, I'm going to skip this one. I've written extensively about my work using AI to understand issues of bias, to understand why it is the world gets treated differently. You are welcome to go search Vivienne, Ming, and Sokos Labs online, and you can see some of those stories and some of that work. It's incredibly important, but I wanted to focus some of my remaining time on newer work. In fact, I might jump through a few slides here and focus on the things that I'm working on right now as we head to a close. So I've had this chance to work on looking at bias, looking at how being named Joe versus Jose changes your career outcomes. In this case, I happen to be in Manhattan right now. You're seeing a map of Manhattan that was part of a system I helped build to predict manic episodes in bipolar sufferers, just using mobility data off of an Android phone. At the time, we used gyroscope, accelerometer, GPS, and we looked importantly for changes in that data rather than some static profile. And we could see evidence of oncoming manic episodes and people diagnosed with bipolar, manic depression. We could see it in some cases weeks before they were aware it was happening to themselves. And this little heat map here doesn't represent the entire system, but it was thrown together at the time to understand how one person in particular had donated their data, someone suffering from bipolar, and we actually could identify parts of town where they were more likely to become triggers for episodes than others, and show that here. Most of these things you're looking at, though, projects from earlier points in my career, in fact, I think all of them, except for the education example, were purely philanthropic. Every one of these projects I did either as an academic or in my free time because I thought they should happen, because I could build something that could help other people. And that it was more important to me that that existed in the world than that every idea I come up with became a nature paper or a startup. And this is another one of those examples. What you're seeing now is a big social network. I'm not going to name the company, but a big company came to me in the context of my philanthropic work and said, what's the biggest untracked predictor of productivity across our entire company, a company of nearly 500,000 people? And long before COVID entered all of our lives, I had a chance to do a contact tracing project where 70,000 employees volunteered to have their interactions tracked in real time. And from that, we built not the org chart of the company, but its actual social network. And we did something kind of cool with it. We actually treated that social network, that network, like it was a deep neural network. Every person was a node. Every connection was a weight. And we took global productivity numbers for the entire company plus individual numbers, and we used essentially an augmented version of backpropagation to backpropagate global productivity all the way down to individual employees and their contributions. That probably sounds crazy, but what we found, the biggest untracked driver of productivity, when we track everyone's interactions and in a subset of people, their actual conversations, was that it was people that made sacrifices, individuals that helped other fellow employee members do better things. That turned out to be the biggest single driver of productivity that wasn't being tracked inside this company. And what was fascinating is when we did psychological models on subsets of these employees, had them take classic survey assessments, the people that had those big numbers, they helped everyone around them, even though it didn't necessarily benefit themselves, all scored extremely highly in one specific psychological construct, purpose, something I mentioned before. And purpose in psychology is defined as having something that's bigger than you, something that would take more than a lifetime to complete. What we found in this work is a sense of purpose is actually the freedom to make a sacrifice, to do something truly selfless that could change someone else's life. And I'm going to take a moment before I close on some new work I'm doing to say that that was, for me personally, a big discovery. Because I've dragged you here through a bunch of absurd stories of work I did, some of which maybe I did before you were even born, certainly before some of you ever got involved in machine learning. But that isn't the start of my life. Just a few years before, I worked on that CIA project on facial analysis. I was homeless. And I had given up on life. I'd been told that I would be this amazing person that would win Nobel Prizes. And when I wasn't the smartest person in the room, I thought, why am I even alive? What is the point of any of this? And in 1995, I was ready to end my life. And in that moment, instead, I found a purpose. My purpose happens to be very human and grounded, but a purpose can be anything that you're willing to make a sacrifice for. For me, how do I live a life that makes other people's lives better? If I'm never going to be happy, maybe that's okay. If I can help other people be happy, if I can make a difference in their lives, that simple little realization, that has nothing to do with AI and ML, was what restarted my life. And 5 years after a very dark moment where I considered ending it, I found myself back at my undergraduate alma mater that I had actually flunked out of years before. And I did my whole undergrad in a single year and got perfect grades. I got to go on and build cyborgs. I got to do so much. I invented technologies that help people be alive, change the course of their life, get them a job. And none of it should have happened. If you want to know why I do what I do, why I'm willing to build these things and give them away, it's because that's the sacrifice that gets me out of bed in the morning. That's the thing that I love about my work. And it's the best job in the whole world. It's a job that can be expensive sometimes. But what's important is I started doing this long before any of my companies found success, long before it was a trivial thing for me to throw some money at starting a new project. I worked, for example, on that project to reunite orphan refugees with extended family using facial analysis at a time when I didn't know how I was going to pay the rent. I had a new baby and a startup nobody wanted to invest in. And we worked on that project anyways, because it had to happen. People that can see machine learning for more than an intellectual exercise, for more than a way to get rich. And it's fine if that's what you're after in your life. But those people who can see it as a tool to change the world, a tool to build better people, including themselves, they're the ones that are going to take this tool and genuinely change the world. So I promised I was going to close out here. Let me touch on some things I'm working on right now. Starting with a project. I'm on the board of the Robert F. Kennedy Human Rights Foundation, and I also have a personal project called the Inclusion Impact Index, an economic model of what kind of policies, not just in the US, but around the world, actually change and make the world more economically inclusive for women, for people of different races, for LGBTQ individuals, but for everybody. And what we are doing, the geeky, nerdy, fun part of it, is actually combining a deep embedding, but in this case, not of language, but of policy data. Everything the census puts out about a given city or state or province, everything we can find about economic policies within that region, every law that gets passed, all of the data on inclusion or lack thereof that we can get our hands on, hundreds and thousands of variables deeply embedded, modeling all of these places across the world. And then from that deep embedding, a reinforcement learning model, trying to learn the relationship between the policies represented in that embedding and outcomes year by year. For example, with the Inclusion Impact Index, we're about to release a new version of this feature. And the idea is that a mayor of Birmingham, Alabama, or Birmingham, England, can actually go to the site and get a recommendation. Here are 3 policies that will create more jobs. It just so happens those jobs will be created by women. Here's a policy that will create more patents for Singapore. It just so happens that the people who will have created those patents, the founders of those companies, will be LGBTQ. What policies actually make a causal difference? It's been really cool working in that space. But one of the great things is a lot of my current work goes back to where I started, building cyborgs, or at least neurotechnologies. I have 3 new projects we've launched, 3 new companies, in fact. One using a large language model combined with EEG data, brain waves, to actually model creativity and help creatives expand their work and have a bigger impact. It's actually based right here in New York City. Another former postdoc of mine, a company called Optoceutics, is using one of the fanciest light bulbs you'll ever see to induce 40 hertz gamma oscillations in across your brain, but particularly in certain frontal networks. And it also combines in gaze tracking. And why is this nerdtastic information useful? Because it seems like, and we have wonderful research we've published, showing that it treats Alzheimer's, reducing both the biological and behavioral symptomology. And I'm even PIing a study now to look at whether it affects major depression. And the great thing is, you could read a book by this light. Imagine you have a family history, a genetic predisposition for depression, and you're struggling at university, and maybe an hour a day reading a book could help you. And without machine learning, neither of those projects are possible. And my final new initiative is also a startup called Dionysus. And we're looking at something that it turns out so few people are looking at, which is postpartum depression and perimenopausal depression and hormone therapy. And here, what we're combining is ML, language models, modeling in real time from people's natural interactions, stress data and personality factors, the thing that make you you and unique, and combining it with epigenetic data. And we have the first clinically validated system to actually predict postpartum depression before delivery. This is economically a multi-billion-dollar a year disaster, even in the United States. But the response of the industry, and it's an understandable one, it's a justifiable one, even if I disagree with it, is that it just doesn't make economic sense to treat every mother because we don't know who really needs it. 15% of mothers, perhaps, based on one estimate. So they wait. They wait for those mothers to experience depression and let it happen. And here, by combining machine learning and language analysis with epigenetics, we can do the least sexy thing you can imagine doing with artificial intelligence. We're changing the economics of postpartum depression and other hormone-related mood disorders. And we're finally getting the chance to actually help someone before they need it. The chance to change that life and help make certain that mother is right there from day one to be a part of their new baby's life. And I love the fact that I get to do this. I love this idea that I get a chance to help people build a better person. And partly that's because that's what I got to do. If you haven't figured it out, I wasn't born a woman. After my time living on the streets and then finding some success in academia, I decided I could make myself a better person. And that better person was me. That better person was Vivienne. I also thought life was too easy. I wanted to do it going backwards in heels. But estrogen is the greatest drug ever. And through its help, I got to be this different person. A person who's worked on all these projects that would otherwise not exist. It's an amazing idea that we can make changes in our lives and that we can build tools to help other people do the same. In fact, and I will close here, I mentioned several projects we've done using machine learning to study large populations of people and identifying purpose. It's one of the biggest drivers of positive long-term life outcomes, as well as productivity. And one way to think about purpose, this idea that there's something bigger than you, something that you're willing to make a sacrifice for, is this old saying: the world gets better when old men plant trees. Even though those old men will never rest under the shade of that tree, the world is made better because they did this thing. Well, that's what I'm talking about. We have the chance to plant trees when we do this work. When we take this tool, simultaneously the most overhyped and yet also underappreciated tool of the modern world, machine learning, and we can go out and plant trees and help other people, even if it doesn't directly benefit us. So that's what I'm asking all of you to do today. I want all of you to take everything you've learned from this entire conference, every vision you've had, every moment that sparked something in you, something amazing. I want you to take that tonight. Don't wait. And I want you to go out and plant a tree. And someday, people will rest under its shade, and they will be better for it. And it will be because you made that sacrifice. You saw that there was something better in the world that no one else could see, and you had the tools to make that change. So thank you so much for taking some time and listening to me race through way too much stuff. And if anyone ever wants to follow up with me, I'm very easy to find online. Drop me a note, connect with me, ask me a question. I love helping young new researchers, entrepreneurs, and just do-gooders figure out how to make their projects work. That's my pay it forward. So reach out to me and let me know if I can help you. And if you don't need that help, it doesn't matter. You're amazing already. And now is your chance to plant a tree. Good night.